Hello, everyone. Welcome to the RCNP course. In this part, we're going to introduce the policy-based routing. And firstly, let's see the overview of this policy. PBR, which stands for policy-based routing, is a technique that forwards and routes data packets based on policies. So actually, it's totally different from the routing protocols we had just introduced. It features stronger control capabilities over data packet forwarding than common routing protocols. This course focuses on the principles and the configuration of PBR. From here, we can also know that PBR is more focused on the control of data packets forwarding. And let's see the difference between common routing and PBR. If it's a common routing, now here is an IP packet. And for this IP packet, in the IP header, you can see the destination IP address. And actually, the common routing of data packets is based on the destination IP, because the router, after receiving this packet, it will check the IP routing table to find if there is any entries can match the destination IP. If do, so it will forward the packet based on the guidance of the entries in the IP routing table, right? For example, after checking the IP routing table, the packet has been sent to the destination on the left. And for the other packet, it's sent to the destination on the right, right? While different from that, if it's PBR, let's see. Now, here is a packet which source IP is 3.3.3.3. And then after checking, pay attention here, after checking the policies on the router, we find a policy which can match these packets. And then following the guidance of the policy, while it's not the routing table, based on the policy, we send the packet to 1.1.1.0/24. And maybe here comes some other packets. And based on their, no matter protocol type or packet length, we can also find that maybe they have been matched by some of the policies. And following the guidance of these policies, we forward the packets to the right to 2.2.2.0/24. Okay, so this is the difference between PBR and common routing. PBR is based on the parameters we have defined in the policies to distinguish the packets, while the common routing is based on the destination IP address. Okay, after knowing the difference between them, next, let's see the principles and the application scan rules of PBR. PBR matches data based on the source IP address, source and destination IP address, protocol type, port number, or packet length, and implements policies on matched data. So the parameters you see here, no matter source IP or destination IP, packet type, packet length, port number, here are all the parameters that we can use to define a policy. Right? For example, we can distinguish the packets based on their protocol type, or based on their port numbers, based on even their packet length, right? And then forward data from the specific egress or set the data priority is the action that we can do to different types of packets. For example, for the source IP address, which is 1.1.1.1, we said that the egress is maybe G00. For the source IP, which is 2.2.2.2, the egress is G02, right? Or we can set the data priority. For example, we can change the priority in the IP header, right, to distinguish these packets. And it can be used, you can see, it can be used for queues. For example, in queues, we can maybe set the priority or the preference of different packets based on the priority value in their IP header. So it says that PBR applies to security, queues, traffic offloading, and other scan rules. Right? By modifying the tolls or DSCP fields of data packets when multiple egress exists. And in the campus network, we can use it to, for example, to distinguish the packets to the internet or to the maybe education network, right? Or in the enterprise network, it's maybe commonly seen that for an enterprise network, there could be multiple egress, right, offered by different maybe ISPs. So based on this, we can maybe distribute the packets to different egress, right? Okay, this is about the application scan rule or PBR. And the next, let's see the implementation process. PBR takes precedence over common routing. It means that when we receive a packet, for example, here, input the data packet, firstly, we should figure out if there is PBR or not. If there is no PBR, so you can see, we will operate the packet based on the common routing. While if there is maybe a PBR, so let's see, we should check the mesh statement. And if we cannot find any entries that can match this packet in the PBR, so it will be operated by the common routing. While if there is, for example, we can find a matched entry, and we should check if the action is permit or not. If it's not permit, it will also be operated by the common routing. While if it's permit, so if it's permit, there must be an action defined by the PBR. So we will execute the PBR policy, means we will operate the packet based on the action in the matched entry. Right? For example, set the next hop, set the priority, set maybe the egress ports, these kind of actions. Okay, this is the overview of PBR. Actually, it's quite easy to understand, right? And next, let's see the configuration. The PBR configuration procedure is shown here. Firstly, we should create a roadmap and match data based on the ACL and define policy actions. Run the IP policy command on the specified interface to apply the roadmap. Okay, this is the procedure. And the router checks data received over the interface and executes the specified policy on matched data. So let's see, step by step. Firstly, creating a roadmap. The router implements, based on a route map statement, a routing policy on data packets that meet conditions. And if it's permit, you can see, if it's permit means that the router implements the policy on data packets that meet conditions. Deny means the router does not implement the policy on data packets that meet the conditions. And the last is the sequence. The range of the sequence number is from 0 to 65535. And the sequence for executing roadmap statements. Here are the parameters you can see in this command. Okay, and different from the permit or deny in the ACL, actually, no matter it's permit or deny, it will not affect the packet forwarding. It's permit do not mean that the packet is permitted to forward. Deny do not mean that the packet is not allowed to be forwarded or the packet will be blocked. Right? It will only affect that if the policy will be implemented on the data packets that meet the conditions. And the command you can see here, roadmap. First is the name, roadmap name, and next is permit or deny, and then the sequence. Okay. The last deny or roadmap statement is used to perform IP routing on traffic that does not match PBR. Because for the packets that cannot match PBR, we still need to forward them based on the common routing. So there must be a deny all entry in the roadmap. Okay, and the next is a matching rule. If matching rules are defined, PBR is performed only on data packets that match the rules. While if no matching rules are configured, PBR is performed on all data packets. And to configure or to define a matching rule, here what we use is the ACL. You can see match IP address, and the next you can use the match IP address access list number or name. Access list number means the number of the ACL, right? Name means the, if we use name the ACL, so you can use the name of the ACL here. For example, match IP address 1, match IP address 2 means we will match the IP address which is limited by ACL 1 or ACL 2. And next, match the layer 3 data packet length, match length, minimum length and maximum length is used to maybe limit the range, okay, the range of the packet length. And next, after knowing the matching rule, next is about the egress. Define the operation following rule matching. For example, set the next hop for data packets that matches the rule, or check the policy-based routes and then the routing map. You can see if we want to define the egress for the data packets, you can see set interface type and number. For example, set interface G01, G02. Okay, or you can use set IP next hop IP address to set the next hop of this package. Okay, it can be different from the next hop in the routing table. Okay, and which is spatial is here. The spatial next hop define the implicit next hop address when there is no explicit route to the destination network. And set, which is different from here, is that you can see checks the routing table and then policy-based route. And the command actually is different. Set IP default next hop IP address and IP. This is the spatial next hop. After using this command, we will check the routing table first and then the policy-based route. Okay. And the last step is to apply PBR to a port. Apply PBR to an inbound interface. So in this case, PBR is first performed on data entering the router over this interface. And PBR must be applied to an inbound interface instead of an outbound interface of the data package. Because if we apply it to an outbound interface, you can maybe think about it. When will a packet be operated by an outbound interface? Now, for example, I have a router. After receiving these packets, I will check the IP routing table and find the next hop and the outbound interface. Then the packet will be operated by the outbound interface. So if we enable it on the outbound interface, means that we will check the routing table first, and then it will be operated by PBR. Actually, it will not take effect. So this is the reason why it must be applied on the inbound interface. On the inbound interface, IP policy and the route map followed with the name of the route map. And if you want to check, you can use a show IP policy to check the PBR. Okay, after knowing the configuration of policy-based routing, and next, let's see a case. Now we want to select an egress based on the data source and route other data through the default routes. And the requirement is shown here. Data from 192.168.1.0 to the external network is forcibly routed through ISP1. Okay, and ISP1. And data from 192.168.2.0 to the external network is forcibly routed through the ISP2. To satisfy this requirement, let's see the configuration here. Firstly, we should use the ACL to distinguish them. So access list 1 permits 192.168.1.0, 000255. Access list 2 permits 192.160.2.0, 000255. So in this way, we have distinguished the packets from these two cells, right? And then is a configuration of root map. Root map PBR here, this is a name, right? The name of the possible root here is PBR. Permit 10. 10 means actually this is the index, okay, index ID. Match IP address 1. Here, IP address 1, this number indicates ACL1, right? Set IP next hop 100.1.1.2. So we have set the next hop to, you can see, to 100.1.1.2. From the figure, we can see the next hop is the ISP1. So we can satisfy the first requirement right now. And then root map PBR permit 40, match IP address 2, set IP next hop 200.2.2.2, means the packets from subnet 192.168.2.0, the next hop is ISP2. And then we should configure it on the inbound interface. So for all these packets, no matter from the 1.0 or 2.0 subnets, the inbound interface is the same, it's G010. So interface gigabit Ethernet 00, IP policy root map PBR. So we have enabled it on the inbound interface. Okay. And in this way, the packets from these two subnets can probably be processed by the router. While for the other packets, they should forward it based on the common routing. So we should configure, you can see default route here. IP route 0.0.0.0, 0.0.0.0, 100.1.1.2, and the second one, 200.2.2.2. And here 20 means we are modifying the preference of these default routes. Okay, means that by default we will use the default route with the higher priority, and if maybe the default route has a higher priority, do not take effect, or it's 40, so we will use the other one. Okay, this is about the configuration of PBR and default route. And since here the next hop is ISP1, ISP2 is the external network, so we should use the NAT here. Let's see. Access list 1 permits 192.168.1.0 and 0.0.0.255. Access list 2 permits 192.168.2.0, 0.0.0.254. And these two commands are used to configure the NAT, IP net inside source list 1, interface G01 overload, and IP net inside source list 2, interface G02 overload. This is the common configuration of the NAT, right? Okay, this is about a case that we use the PBR to set the next hop of different packets from different subnets. Okay, so about this part, let's make a summary. With stronger routing capabilities and use flexibility than traditional routing, PBR enables a router to select a forwarding path based on the destination IP, protocol type, packet length, source IP of a data packet. It's commonly used in network environments with two egresses. During PBR configuration, pay attention. Don't forget the NAT, don't forget the NAT. Okay, and next, let's see some questions together. How does a router forward a data packet that matches both common routing and PBR? This is asking you about the preference of the common routing and PBR. And as we know that PBR has a higher preference, so we choose B. The router preferentially forwards the data based on PBR. Of course, it has a higher priority. And next, what are the data packet parameters used to formulate PBR policies? It's a multiple choice, means which of the following parameters can be used to define a PBR policy. First, data packet length is true, and B, source and destination IP is true. C, source IP, D, destination IP. Here we choose A, B, C, D. All of them can be used to define a PBR policy. And next, what is the difference between the set IP next of IP address command and the set IP default next of IP address command? We have mentioned it, right? The difference between them is that if we use the first command, set IP next of IP address, we will check the PBR first. While if we use the second command, set IP default next of IP address, so we will check the routing table and then the policy-based route. So about the answer here, we choose is B, right? B. The second command enables the router to check the routing table and then policy-based route. Okay, this is about the PBR. That's all for this part.